Good morning to one and all. In today's class, we are going to discuss about methods of voltage control. So before going to the controlling techniques, methods of voltage control techniques in power system, first of all, we should know why should we control voltage in a power system. So is that necessary to control the voltage? So why is the voltage always supposed to be constant? So why the voltage will vary? Why should we remains it constant? Because yes, voltage. So it is very important to maintain the voltage value, voltage level constant. Why? Because wide variations in the voltages, wide variations in the voltages may occur errors in the operation equipment, and it causes malfunctioning of the equipment, and it leads to the damage of the equipment, deterioration or damage of the equipment. So that's why the voltage variations we have to be minimized. So we can't completely reduce the voltage variations. So so the voltage where there is a limit, there is one tolerable limit will be there. So the voltage variations will be occurred up to particular limit, that is plus or minus 6%. And most probably uh, main cause of this voltage variations in the power system is due to the load. So due to changes in the load, the voltage variations will occur. So it is mandatory to maintain the voltage almost constant, at least plus or minus 6%. Within the tolerable limit, we have to maintain the voltage constant. So for that, it can't. So for that, we need some devices based upon the requirement. So to maintain voltage in a power system, so in order, it is a desirable that the voltage is maintained constant. So to maintain the voltage constant or in a controllable, tolerable limits in the power system, so there are certain devices out there. So these are the methods of voltage control in power system. So different control techniques have their own applications, as has their own criteria. So some methods are suitable for the generating stations only. Some are suitable in the transmission side. So some are suitable at the distribution side also. So based upon the, so everywhere you have to maintain the voltage constant. So generation side, irrespective of generation side, transmission side, or distribution side. So everywhere you need to maintain the voltage level constant. So see, these are the devices used to control the voltage in a power system. So first one, excitation control or voltage regulators at generation side. So this method will be suitable for the generation side for voltage control. So if you want to control the voltage especially in the generation side, so this method is most suitable. So using excitation control or voltage regulators. So next one is by using tap changing transformers. So tap changing transformers. So in this tap changing transformers also there are two types. One is on load tap changing transformers, another one is half load tap changing transformers. So these both will be used for the transmission side. Transmission side, this will be useful. So using induction regulators also, by using induction regulators also, we can control the voltage. So, and this will also is suitable for the transmission side. So by using shunt reactors, shunt capacitors, synchronous condensers, so we can improve the voltage, or you can control the voltage within the tolerable limits. That I have already told you, tolerable limits is plus or minus 6% of the rated voltage. So that is a tolerable limit. Up to that limit, so the device may not damage that much level. So beyond that, so definitely the equipment will get deteriorate. So we should maintain the voltage always constant or within the tolerable limits. So we can't do it on our own. So we need to maintain that voltage level. We need some controlling equipment. So see, next, first method, excitation control or voltage regulators at generation side. So excitation. So here excitation. So here the voltage controlling is based on excitation control or regulating the voltage at generating stations. So we know very well the EMF generated by the alternator will depends upon the excitation current. Excitation means giving some supply to the um, machine to generate field current, to generate magnetic field. So the machine, any machine on the self itself, it can't generate. Some machines only it will generate EMF. So other machines will generate with the help of this excitation current. Excitation current is nothing but excitation means providing some supply to a machine to generate field current. So that is nothing but excitation. So we know variable. Suppose if you take a machine, suppose this is an alternator. This is an alternator. So the induced EMF will depends upon the excitation control and the whatever the voltage appearing across this alternator. This is nothing but the terminal voltage. Generally, we will denote it with V. So V will depends upon the EMF generated in the machine minus drop. Drop you can represent it with I into Z. Impedance. This is the current. So we will represent with this. E is equal to E minus IZ. So as the load current is goes on increasing, armature current is also increasing. So which leads to the voltage drop in the armature itself. So in that case, if the voltage drop is more, means there is a huge difference between the terminal voltage and the induced EMF. So whatever the induced EMF, if the voltage drop is more, means whatever the EMF is induced will not appear at the terminals. Not appear at the terminals. Suppose this is your circuit. This is the induced EMF. So suppose assume the resistance will be there. Here some load is connected. So the voltage across this will be considered as a terminal voltage. So VT will be equal to, so whatever the EMF generated in the alternator itself, we will consider it as E. So here there will be some impedance. So the current flowing in this circuit, let it be I. So therefore VT is equal to E minus induced EMF. Whatever the EMF available here, E minus I into Z. I into Z. Suppose if the load current is increases, armature current is also increases. So if the armature current is increases, means here voltage drop will be more. So if the voltage drop is more, means there is a huge difference between terminal voltage and the induced EMF. So um, you should maintain that voltage drop within the tolerable limits. So to maintain the voltage drop, to minimize the voltage drop, so we are providing alternators with excitation control or automatic voltage controller. Here automatic voltage controller. So anyone is same. So by providing some excitation, some extra energy to it, so here we are maintaining the voltage, terminal voltage to our target level. So there are two types of automatic voltage regulators. Automatic voltage regulators means, so here the value will be fixed in the controller whenever the particular voltage, terminal voltage is less than that tolerable limit automatically. So this regulator will regulate the voltage, will provide some extra voltage to maintain that. So by regulating the voltage, we are minimizing the voltage drop within the tolerable limit. So in this excitation control or automatic voltage regulator systems, so there are two types of automatic voltage controller. One is Terrell regulator, another one is Brown-Boveri regulator. So here, both are used for the both voltage automatic voltage regulators will be used in the generating stations itself. So what is the purpose of automatic voltage regulator is it detects the terminal voltage and compare it with reference voltage. Always in the regulator, we will set some voltage. We will set some voltage. So simply it's just like a comparator. Suppose whatever the voltage appearing in the power system will be sent to the controller. In the controller itself, already one reference voltage will be fixed. Always this automatic voltage controller will always check the value with the reference quantity. If the value is less than the reference quantity, immediately it will supply that drop. So that is its purpose. It always compares it with the reference voltage. The difference between the detected voltage and the reference voltage is called error voltage. Always that error voltage will be uh, provided by the controller, automatic voltage controller itself. And comes to the applications. So here, by using voltage controller, we can control the voltage by controlling the excitation. By controlling the excitation, we are controlling the voltage. And this method will be only suitable for the generating stations. So we won't use this method in transmission side as well as distribution side. Very rarely we will use. And next comes to the applications. Excitation control method is suitable for short lines only. Suppose if you want to use it transmission system, it is only satisfactory for short lines. For longer lines, uh, so it is not that much feasible method for longer lines. Means it is not that much suitable. It is not that much suitable for the longer lines. So that's why we are using this excitation control or automatic voltage regulators at generation stations only. So if you want to use the same method for transmission lines, so it is restricted to short lines only. So if there are longer lines, this method is not feasible. Means it is very difficult. So for the transmission lines, long transmission lines are there. Suppose at one target point we have to maintain the voltage constant. So which is far away from your automatic voltage regulator. So fixing that regulators and providing the excitation by using this method is very difficult. Whenever if you want to if you want to minimize the voltage variations far away from the end is very difficult by using this method. So this method is not that much feasible for longer lines. So it is only suitable for the short lines. Next method, by using tap changing transformer. So here tap means the switches are provided here. So whenever mm, so this is also one of the method by using tap changing transformers. Here tappings means switches. Different several switches are available here. Suppose if you want to draw the tap changing transformer, the primary winding of the transformer is similar to your power transformer only. But when it comes to the secondary, so many tappings are available. So many tappings are available. See here, just like so wherever you want to connect, so many, so these are called as tappings. So due to the feature it will be called as tap changing transformer. Or see here, one switch will be there. So wherever if you want to connect, wherever if you want to close the switch, the particular tapping you have to close. So by using this tappings, so due to this tappings only, this transformer will be referred as tap changing transformer. So by adjusting the these tappings, we can adjust the EMF of the secondary of this transformer by varying the number of secondary turns. So we can directly changes the secondary turns. So by using this tap changing, so we can adjust the turns ratio. If the turns ratio is changing, means obviously the voltage or the EMF generated in the secondary will get changed. Though how we are choosing these tappings means based upon our requirement of the voltage drop. If the voltage drop is more means, so accordingly it will changes the tappings. So here basically there are two types of tap changing transformers. One is half loading tap changing transformer, and then one is on loading tap changing transformer. So in the next class, we will continue this tap changing transformers. Thank you.